Hello guys. Welcome back to our channel AI Unleashed, where we explore the fascinating world of AI and machine learning. Today, we have an exciting topic lined up for you, the top 5 essential AI and machine learning concepts for beginners. Whether you're a student, a professional, or just someone curious about this cutting-edge field, this video will provide you with a solid foundation to kickstart your learning journey. So, without further delay, let's dive right in. Let's start with supervised learning. Supervised learning is a branch of machine learning in which the algorithm learns from data that is already labeled. The training data consists of input features along with their corresponding output labels. The algorithm's objective is to learn a mapping between the input features and the desired output by identifying patterns and making predictions. For instance, in a classification problem, the algorithm is trained with examples where each input is associated with a specific class or category. It learns to classify new, unseen inputs based on the patterns it discovered during training. On the other hand, in a regression problem, the algorithm learns to predict a continuous numerical value based on the input features. Various supervised learning algorithms are available, each with its strengths and weaknesses. Linear regression is used to model the relationship between input features and continuous output variables. Decision trees use a hierarchical structure of rules to make predictions. Neural networks, inspired by the human brain, are composed of interconnected nodes and are capable of learning complex patterns. Supervised learning has diverse applications, such as spam email classification, image recognition, and sentiment analysis. By learning from labeled data, supervised learning algorithms can make accurate predictions and automate decision-making processes in many domains. Moving to the next one is unsupervised learning. Unsupervised learning is a branch of machine learning that deals with unlabeled data. Unlike supervised learning, unsupervised learning algorithms learn from data without any predefined output labels. The primary objective of unsupervised learning is to discover patterns, structures, or relationships within the data. One common technique used in unsupervised learning is clustering. Clustering algorithms group similar data points together based on their inherent similarities or proximity in the feature space. By identifying clusters, the algorithm can uncover hidden structures or categories within the data. Another technique in unsupervised learning is dimensionality reduction. In many real-world applications, datasets can have a large number of input features, which can lead to computational challenges and overfitting. Dimensionality reduction methods aim to reduce the number of input features while retaining important information. This can be achieved by transforming the data into a lower-dimensional representation that captures the most relevant features. Unsupervised learning algorithms are valuable for tasks such as customer segmentation, anomaly detection, and data exploration. The next one is neural networks. Neural networks are captivating computational models that draw inspiration from the structure and functioning of the human brain. They comprise interconnected nodes known as neurons, which process and transmit information. Neural networks have the remarkable ability to learn intricate relationships in data through a process called training, allowing them to accomplish tasks like image classification, sentiment analysis, and language translation. Deep learning, a subset of machine learning, heavily relies on neural networks and has brought about revolutionary advancements in numerous domains. The basic building block of a neural network is the neuron, which receives inputs, performs computations on them, and produces an output. Neurons are organized into layers, with the input layer receiving the initial data and subsequent hidden layers gradually extracting higher-level features. The final output layer produces the desired output based on the learned patterns. During training, neural networks adjust the weights and biases of their connections iteratively to minimize the difference between predicted and actual outputs. This process involves forward propagation, where data flows through the network, and backward propagation, where the network updates its parameters based on the calculated error. Neural networks excel at capturing complex patterns and nonlinear relationships in data, making them particularly well suited for tasks with large amounts of data and intricate structures. The advent of deep learning and the availability of vast computational resources have propelled breakthroughs in image and speech recognition, natural language processing, autonomous driving, and many other areas. Do you know about feature engineering? Let's see. Feature engineering is a critical process in machine learning that involves selecting and transforming input data to create meaningful and relevant features for algorithms. It encompasses the analysis and understanding of the data, identification of valuable patterns or relationships, and the creation of new features that effectively capture essential information. By engineering good features, the performance of machine learning models can be significantly enhanced, as they are provided with more meaningful representations of the data. The process of feature engineering requires domain knowledge and a deep understanding of the data being used. It involves techniques such as scaling, encoding categorical variables, handling missing data, and creating interaction or polynomial features. Feature engineering aims to extract the most informative aspects of the data and transform them into a format that machine learning algorithms can effectively utilize. Well-engineered features can improve model accuracy, reduce overfitting, and enable algorithms to generalize better to unseen data. They can help uncover complex relationships, capture important attributes, and mitigate the impact of irrelevant or noisy features. Feature engineering is both an art and a science, as it involves a combination of creativity in data-driven decision-making. The last one is evaluation and validation. Evaluation and validation are essential steps in machine learning to assess the performance and generalization capabilities of models. Various metrics and techniques are employed to accomplish this, including accuracy, precision, recall, F1 score, and cross-validation. The evaluation process facilitates the comparison of different models, selection of the best-performing one, and identification of potential issues such as overfitting, when the model performs well on training data but poorly on new data, or underfitting, when the model is too simplistic to capture underlying patterns. To evaluate a machine learning model, it is common to split the available data into training and testing sets. The model is trained on the training set and then evaluated on the testing set, providing an estimate of its performance on unseen data. Accuracy is a commonly used metric, measuring the proportion of correct predictions made by the model. Precision quantifies the proportion of correctly predicted positive instances out of all predicted positive instances, while recall represents the proportion of correctly predicted positive instances out of all actual positive instances. The F1 score combines precision and recalls into a single metric, providing a balanced measure of a model's performance. To further enhance evaluation, cross-validation is employed. It involves partitioning the data into multiple subsets, training and testing the model on different combinations of these subsets, and aggregating the results. This technique provides a more robust estimate of a model's performance and helps mitigate the potential impact of data variability. By thoroughly evaluating and validating machine learning models, we gain insights into their strengths, weaknesses, and ability to generalize to new data. This process aids in making informed decisions about model selection, fine-tuning parameters, and improving overall performance in real-world applications. And there you have it, the top 5 essential AI and machine learning concepts for beginners. We hope this video has shed some light on these fundamental concepts and inspired you to embark on your AI journey. Remember, the field of AI is vast and ever-evolving, so keep exploring, learning, and experimenting. If you have any questions or want us to cover more topics, let us know in the comments below. Don't forget to like, subscribe, and hit that notification bell to stay updated with our latest videos. Until next time, happy learning.